Hey everybody, I just wanted to take a minute to explain to you what conjugate acid-base pairs were. Okay, and so this is in your book on page 675, and you can open up and read along. Or read along, like I said, you guys are going to read it, but at least you know what it is. Okay, now here's the idea. Anytime you have an acid, and keep in mind this acid is an acid because it donates a proton. Okay, anytime you have an acid, acids will typically react with a base. Okay, acid plus base. Okay, and that's something you may remember from a different chemistry class. But what you need to know from here is that you can identify the products. So when this thing, this HNO2, nitrous acid, loses a proton, it forms NO2 minus. That is its conjugate. Okay, notice those two things are related. Okay, and the same is true with water. If we look, water here is related to the hydronium ion, and water has gained a proton on the product side to become the hydronium ion. So this acid, nitrous acid, has a conjugate base on the product side that is the nitrite ion. And then the H2O, the water, has a conjugate acid on the other side that is the hydronium ion. So conjugate acid-base pairs are related to each other, and it just gives us some terminology to name the products of the reactants. The products of the reaction, not of the reactants. Okay, so now for this is now a base reaction. This is ammonia reacting with water, and what happens is ammonia gains a proton, okay, and it becomes the ammonium ion. When it does that, now it's a base, and then it forms its conjugate acid. That is the conjugate acid-base pair. And then water loses a proton and turns into the hydroxide ion. By losing a proton and turning into the hydroxide ion, it turns into a conjugate base. So this is your conjugate acid-base pair here, water with hydronium, or with hydroxide. Now I want to also point out here that these two reactions, notice that water can act as either a base when it's with an acid, or it can act as an acid when it's with a base. That's a special property of water called amphoteric, called amphoterism, I guess. Amphoteric is the adjective form of it. So water is amphoteric. It can act as both an acid and a base. Now, let's take a look at this sample exercise, 16.1. And the answers are all down here, obviously. Okay, and so you can look at them, but I just wanted to go over it. So for part A, it says, what is the conjugate base? So we are assuming that HClO4 is an acid, which it is. So what's going to happen when this acid reacts? It's going to lose a proton. Okay, so the conjugate base is going to be that without the hydrogen ion. So that makes that the hypochlorate, or sorry, the perchlorate ion. And it finally turned 9 o'clock in my house. So the conjugate base of this is ClO4 1 minus. And so that's what we do with the rest of these. We lose a proton because this is an acid. So we go H2S will react with whatever. Doesn't have to react with water specifically, but it can react with whatever. And it will lose a proton. So its conjugate will be HS1 minus. It loses just one proton. Okay. Here's this phosphine ion. Form a conjugate base, so it's an acid, so it loses a proton. So The conjugate of this is going to be pH3. No charge because it's losing a charge. Okay. And so you can go down and take a look, okay, at some of the answers there. Now for the conjugate acids, okay, what are the conjugate acids? Well, so we take these and we assume that they are bases. So by finding in order to find the conjugate acid, we have to add a proton. Bases gain protons. So for Cn minus, what is that when it gains a proton? It's HCN. Okay, HCN. And then SO4 2 minus, when that gains a proton, that's going to be HSO4 1 minus. And that's what we see down here. Okay, so just to give a quick recap, conjugate bases are formed by acids losing protons. Now my phone is ringing. And a conjugate acid is caused when a base gains a proton. So, so there's conjugate acid bases.